Hello everyone, this is Dr. B. Mathura, Associate Professor, Department of IT, VNR VJIT, presenting before you a recording on hashing techniques used in data structures. Proceeding further, the agenda of today's presentation will be introduction to hashing, a hash function, hash table, and the types of hash functions used like division method, multiplication method, mid-square method, folding method, hash collision, and how do we remove the hash collision using collision resolution techniques like separate chaining, open addressing, and a comparison of all the hash collision resolution techniques. Proceeding further, introduction about hashing. Why do we go for hashing? Basically, hashing is a technique used to store and retrieve data quickly. Instead of searching for one by one in a list, hashing directly finds the location of the data using a special function called hash function. If we take up a simple example of a library, so in a library, if the books are not being organized properly, just searching for a book without hashing is something like moving to every shelf one by one and then going for a search, which is very tedious task. So if hashing is applied where a book number directly being given, it tells the shelf location where the particular book is available. So hashing makes it searching very fast when compared to the other searching techniques. So proceeding further, to perform hashing, we need a hash function. So what is basically a hash function? A hash function converts a key into an index value of the hash table. So if we basically see the diagram over here, so hash function is denoted with f of x, or usually we also denote it with h of x. So this hash function will help you to find the index where the key is located in a hash table. So hash table is something like a memory dump where the key values will be stored, and searching for the key is possible with the help of this hash function, and we call this procedure whole thing as hashing. Okay, so proceeding further, a good hash function should be very simple. It should distribute the data or the keys evenly. It should reduce collisions, and it should be very fast to compute. So in the hashing, the procedure goes like this. The key is being given as an input to a hash function, where the hash function will produce an index, which we call it as a hash value or a normal index, which will act as an index mapping into a hash table where the actual key is stored in the hash table. Proceeding further, what is a hash table? Hash table can be treated as any data structure or a memory dump which stores the data in an array format. An example given here, we have an hash table which is stored in the form of an array having an indexing from 0, 1, 2. So if I have a list of keys like this, how do we store into this hash table? If I take up a hash function, something denoted like this, where it is x mod 10. So performing for each x element 11 by 10, 11 mod 10, where I'll get an hash index value as 1. So at an index value 1, 11 is stored. Similarly, 12, hash index value is 2, where 12 is stored. So this is how the data is being stored into your hash table using a hash function. Proceeding further, what are the different types of hash functions? Different types of hash functions are, we have division method, simple method, which is multiplication method, mid-square method, folding method. So these are the different types of hash functions which we use popularly in data structures. Proceeding further, the very first method, that is division method. In the division method, we consider this as to be a simplest and the most commonly used hash function, which is defined with a function notation as h of k equal to k mod m, where mod stands for modulo division. So if we take up an example here, if I have a hash table size of 7, usually we define hash table with a value called as m, or with a notation called m. So hash table size 7, and the key value is 50, which is to be stored in a hash table by applying the division method. So if we apply this division method, 50 mod 7 will give me 1. So the key value 50 is stored at an index 1 in the hash table. We'll take up one more example in the next slide. Now if we see the advantages of this particular division method, as it is considered to be a simplest method, it is easy to implement. Fast calculation, simple, but it will create more number of collisions. So collisions are possible if we consider a division method, and if we don't properly choose the table size also, more collisions will occur. So proceeding further with the example for the division method. So here we consider the list of keys which is to be stored in the hash table. The hash function which is used is a simple division hash function, h of x mod 10, where the key 42, when it is given for this hash function, it will give you modulo division of 10 2, where the value 42 is stored at an index 2 in the hash table. Similarly, h of 17, the modulo division of 10 will give me hash index as 7, where at an index 7 value 17 is stored. Similarly, all these keys are stored into the hash table. So modulo hash function division method, it simply maps the indices from 0 to 9 in the hash table. This is a very simple method which can be used. The second hash function, which is very frequently used is multiplication method. In this method, the key is multiplied by a constant value. If we see the formula h of k function notation, h of k equal to a floor of m, where m is the table size as defined, k is a constant value, k is a key value which is given as an input, and a is a constant value between 0 and 1. Preferably we use a particular constant value as defined by one of the author called Donald Knuth. So we can take any constant value between 0 and 1, modulo division by 1. Now when we apply this multiplication method, the advantages is we get better distribution of keys, less dependent on the table size. Since we are using a constant being multiplied, it is less dependent on the table size. The disadvantage is we need to do multiplication and additional calculation which is to be done when compared to the previous division method. So slightly complex calculation. Proceeding with an example of a multiplication method. Here if we take a key 45 and a hash table size of 10 and a constant which is defined by Donald Knuth given as a value 0.618. Usually we consider this as a constant which ranges from 0 to 1. So the first step as per your previous slide is, first we need to multiply the constant value with your key. So 45 multiplied with the key gives you a value. Next, consider this particular value with your table size, that is m. So the index value which we consider here is since we used a floor, so we consider the index value as 8. So key 45 is stored at an index 8 as per the multiplication table. Next, proceeding further with the third division method, that is mid-square method. So as the name says, mid-square method, we are trying to do some squaring operation here. So in this method, how do we proceed is, we take the square of the key, and after squaring, we take the middle digits as an index. So if we take an example here, if I consider the key as 25, the square of 25 is 625, and the middle digit if I consider, that is 2. So the hash index which is considered for this mid-square method will be 2. Now if we take an advantages of this mid-square method, it's a good distribution when compared to the previous two methods. It works well for the large keys, but the disadvantage is we are doing a squaring operation, and a squaring of a large number will take more time when compared to the previous methods. An example for a mid-square method is, first we need to square the key, then extract the middle part or the middle digits of the result. That will be acting as a location of the key element where we store the key in the hash table. Example, if we take 3111 as a key, the square of that will be a number as 96,783.21, and we consider the middle digits as 731, which will be the location of the hash table where of size 1000, where the key will be stored. If we take an example of 16, then 256. Now here, if we consider, we can take the middle digit as 56, but here's considered the last two digits as the key hash key index for storing the key. So you can consider either the middle digits, or you can also consider any pattern in the square value for storing your key in the hash table. Proceeding further with the fourth hashing technique, that is folding method. In this method, the key is divided into parts and then added together. For example, if we take up a key as 1, 2, 3, 4, 5, 6, it is being split into the parts, like considering first 3 digits as one part and second 3 digits as another part. And we perform a sum of it, where the sum will result in a number. Now, if this number is within the range of the size table, then we consider this as a hash index. Say, for example, if the hash table size is smaller, then we perform a modulo division, that is your simple division method. We perform modulo division with a hash table size 100, and then we will get the hash value index. So, your key 1, 2, 3, 4, 5, 6 is stored at an index 79 with a modular hash table size of 100. This is how we proceed with the folding method. Proceeding further, a hash collision. While we performing these hashing by applying different hashing functions, when we obtain a hash index, now during this process, we get a collision. So what do you mean by a collision is, a collision occurs when two different keys get the same index value in the hash table. For example, if we take a small example here, where we are applying a simple division method, where h of k equal to k mod 10, and the given two keys like 25, 35, if we perform this division method, we get a hash index value as 5. Where for the first one, already in the index 5, we store 25 in the hash table. But when we calculate for the next key 35, we get the same index, where already 25 is stored in the hash table. So both want index 5 to store the keys, that is 25 and 35, which is not possible in the hash table. Hash table will store only one value. Now this, we call this as a collision or a simple hash collision. So two keys mapping to the same location in the hash table, we call it as a collision or a hash collision. Why do hash collisions occur? Hash collisions do occur if we don't select a proper good hash function. So collisions can be reduced with the selection of a good hash function. So what are the characteristics to be considered for a good hash function? The hash function should be deterministic. Deterministic in the sense, like whenever you compute for the same key, apply the hash function, how many times you apply, you should get the same hash index value. So that is what we call as deterministic. Next, efficient. Efficient in the sense, the hash function which we have chosen should take less amount of time and space possibly. So that is why we call the time complexity should be less, that in terms of efficiency. Next, the third property which we considered is uniformly distribute the keys. So as we rightly said, every hash function will try to distribute the keys uniformly, but if at all a hash function doesn't distribute the keys uniformly, then it is not said to be a good hash function. So distributing the keys uniformly in the hash table. So collisions happen because of a limited hash table size, even if you don't properly select a good hash function. So which means that collisions cannot be avoided. So it is not possible to avoid collisions altogether in hashing. The best solution for that is, how do we resolve it? How do you handle it? So for that, we take up hash collision resolution techniques, which will be discussed next. So the different hash collision techniques are, we have open addressing, separate chaining. Separate chaining is a technique where we use additional memory along with the hash table. This is a major difference between separate chaining and open addressing. In open addressing, we use only hash table as a memory. So in the case of separate chaining, along with the hash table, we need to have an additional memory. Whereas there is no need of any additional memory in the case of open addressing. So these are the basic differences between these two collision resolution techniques. Now under open addressing, the subcategories, you can also have linear probing, quadratic probing, double hashing, even random hashing. Proceeding further, the first collision resolution technique, that is separate chaining. So collision handling techniques in hashing with the help of separate chaining. So when two different keys get the same index value in the hash table, a collision occurs. Now to resolve this, we use the hashing collision technique, that is separate chaining. What exactly is being done in the separate chaining is, each index of the hash table, it stores the keys in the form of a linked list. That's the reason why we say we have an additional memory. So this linked list is nothing but your additional memory along with your hash table. when considered with the hash table. So if multiple keys come to the same index, they are stored one after another in the list. Example, if we take up an example here, a simple hash division method, a hash function of division method, where h of k equal to k mod 10, and these are the keys which are to be stored in the hash table, 15, 25, 35. Proceeding further, if we apply the simple hashing technique, that is division method, for each of these keys we get the index 5, which is nothing but a hash collision. Now, how do we resolve this? Now, this can be resolved by storing all these keys in the form of a linked list. Stored, the base address of that linked list stored in the hash table, like this. Okay, this is another example where we have 89, 27, 45, 56 and so on, and this is the hash table which we apply. So if we take up this, so when a key 89 is being used, as per the hash function which is applied, you will get an index as 9. So 89 is stored at 9. Next 27, it is stored at 7. 49, it is stored at 9 index, added as a next element in the linked list. So similarly 55 at an index 5, 69, it has been added as a third element to the linked list at the index 7. So this is how the collision is avoided. So at an each index, you're storing more than one value or more than one key in the form of a linked list. But this linked list is said to be an additional memory which is to be considered in separate chaining. Now, if you see the advantages of the separate chaining, it's very easy to implement. Hash table never becomes completely full. Why? Because we are not considering the hash table for storing the keys. We are taking it to store the base address of the linked list, where the linked list can be increased at any size since it is using dynamic memory allocation. Insertion is very simple, but when we consider the disadvantages, it uses an extra memory needed for the linked list. This is the basic disadvantage in the separate chain. Searching becomes slower if the chain becomes large. As we know, for a search operation in a linked list, it takes big O of log n. So the searching operation is also takes more time. Now coming to the second hash collision resolution technique called as open addressing. In open addressing, all the elements are stored in the hash table itself. This is the primary difference between the separate chaining and open addressing. So all the values are stored in the hash table itself. No additional memory. If collision occur, another empty location is being searched in the hash table. So the main idea in the open addressing is when one index is occupied, search for another empty location. Store the element there. Okay, so this is the main idea of open addressing. The different types of open addressing is we have linear probing, quadratic probing, double hashing and random hashing. Proceeding further, one of the type of your open addressing, that is linear probing. In linear probing, if one position is full, we check for the next position sequentially. Sequentially means one after another. We denote the sequentially with the notation of I, where I will be ranging from 1, 2 and so on. So I starts from 1 and so on. So sequentially it goes. So h of k is your original hash value, I is the prob number which ranges from 1 to n, and m is the hash table size. Proceeding further, this is an example of linear probing where the hash table size is 10. The hash function which is used is a simple division method, k mod 10. Here, if we try to insert 25, 35 and 45 are the keys to be inserted into the hash table. Applying the simple hashing technique, division method, 25 mod 10 will give an index 5. So where we try to store this value at the index 5. But afterwards, when I apply for 35, where we will get the same index, where already index 5 is already occupied. In that case, we just add an I value 1, where the index will be now changed to 6, which is empty, so it stores at an index 6. Similarly, when 45 is being added, where we'll get the hash index value 5, where 5 is already occupied. So if we add 1, it will go for 6, 6 is already occupied, there we'll add 1, where 7 is empty, we store it 7. So this is how sequentially we store the keys using linear probing. The advantages of the linear probing is a simple implementation. No extra memory needed, but it causes primary clustering and the searching becomes slower. So this is another example where we try to store. Initially the hash table is empty. Next, first we inserted 50. Next, insert 700 at a location 0 and 76 at an index 6. When we try to insert 85, here the location which we got is 1 where it is already occupied. So we go for the next slot available, that is 2. Similarly, when 92 is being added, where already 50 index, the index obtained for it is 1, where in that index 150 is already occupied. So we go for the next slot where already 85 is occupied. So the next slot available, that is 3. So at index 3, 92 will be stored. So this is how the keys are being inserted into the hash table using linear probing. Proceeding further, quadratic probing. In quadratic probing, instead of checking the next cells one by one, we jumps are made using square. So here if we apply, we get something like primary clustering. So to reduce this primary clustering, we go for squaring of your index. That is I square. So in quadratic probing, only the I is being squared. So if we take an example, the same example which we have considered previously, 25 which is stored at index 5, 35 where already 5 is stored as 25 is stored at index 5, so collision occurs, where we will add I with a square. So 1 square 6, so at an index 6 we will store the value 35. Next, when we try to insert 45, when we perform modulo division, we got an hash index value 5, which is again a collision. Now here we apply the I index 1 square where 6 is already occupied. Now we go for an index value 2, which is squared will give me 4. So it will be stored at an index 9. So we are not trying to store in a sequential pattern, but at different locations so that we can avoid primary clustering here. Another example here, initial empty table. First we insert 50, then insert 776. Now here when we try to insert 85, since it is already occupied, so the next location occupied will be 2 as per the 1 square, the next location. Next, when we try to insert 92, now instead of 92 in the case of the previous linear probing, it was inserted at an index 3. Now here we apply square, so 2 square means 4, where it will be identifying the next index, that is 5 here. So 92 is stored at an index 5. So similarly we store all the keys in the quadratic probing using quadratic probing. The advantages of quadratic probing is it reduces primary clustering, better distribution than linear probing, but the disadvantage is it will have secondary clusters. So secondary clusters will be forming in the case of quadratic probing, and it is more complex since we are doing squaring operation. The third method is double hashing. As the name says, we use two different hash functions here. The second hash function will be denoted with h2 of k. h1 of k is the first primary hash function. Secondary hash function will be h2 of k. So the first primary hash function in this example, when we consider, it is simple division method, but the secondary hash function we defined as something like 7 mod k mod 7. So the second hash function has to be decided based on the primary hash function. So as per the example, when we try to insert 25, we get an index as 5, so we store 25 at an index 5. But when we try to index key 35, so where we get an index value as 5, which is already occupied, so collision occurs. Now as per the second hash function, we obtain the second hash function index as 7. So the next position for your index key 35 to be stored in the hash table would be 7. So based on your second hash function which is applied, that is first hash function plus I into h2 of k. Same thing has been applied. First hash function index 5 plus I value which is taken as 1 into the second hash index which we got as 7. Modulo division by 10. So this is this index where the value will be stored using double hashing. The advantages of this is we have a better distribution. It reduces clustering greatly when compared to the quadratic probing and the linear probing where we have primary clustering and secondary clustering there. But the disadvantage is we require second hash function and the implementation is complex. Coming to the last hashing technique, that is random hashing, which is also called as random probing. So in random hashing, random steps are used to find the next empty location. So unlike your linear probing where we go for a sequentially searching for an empty location, or in quadratic we square the index, so prob sequence, wherein we try to identify the empty location. Whereas in the case of random hashing, we take random positions here. So instead of fixed patterns, we go for random positions. So if you see the working pattern of this, if collision occur, it generates a random number, move to the another location based on the random number being generated. The advantages is it reduces clustering, better distribution, but the disadvantage is the random sequence management has to be taken care, and it is slightly difficult for implementation. If we take an example for random hashing, key 25 stored at an index 5, key 35 when we try to find the index where we get the same index 5 where it is leads to a hash collision, and the random jump generated will be 3. So this is a random number which we have considered. So the new index will be 5 plus 3 mod 10. So at an index 8 we will be storing key value 35. Proceeding further, a comparison of all the collision resolution techniques, if we see, as we have already said, separate chaining when compared with the open addressing, it uses an additional memory here. So when compared with the separate chaining with all these open addressing technique, there is an additional memory. Here there is no additional memory. Proceeding further, when we consider the open addressing techniques, in linear probing we have sequential search. In the case of quadratic, we go for square jump. In the case of double hashing, we use 2 hash functions. In the case of random, we use a random jump. Coming to the clustering, in the linear probing, the clustering is very high. We get primary clusters. In the quadratic probing, the clustering will be low. We get secondary clusters. But when we use double hashing and random hashing, it is completely low where we don't get most of the clusterings. Coming to the speed, this is linear probing is simple, better when compared to the linear probing, best when compared to the other previous 2 techniques. In double hashing, in random hashing, it is good. So in separate chaining, the speed is good, and in random hashing, the speed is good. But there are some limitations, like you have to select a random number. So here we comes to the end of the presentation. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.